66 million years ago, something unimaginable happened. A 6-mile-wide asteroid slammed into Earth, releasing energy greater than 1 billion nuclear bombs. Fires swept the continents. Tsunamis raced across ancient oceans. Darkness fell over the planet. It's the moment we're taught ended the age of dinosaurs. But the truth might be far more complicated. Not everything died that day. Some dinosaurs may have survived the initial impact, walking through forests as the skies dimmed, unaware that the world was ending around them, not in an instant, but over days, even weeks. What if extinction wasn't a singular event, but a slow-motion collapse? Today on Armchair Archaeology, we'll trace the final days of the dinosaurs, exploring the fossil record's most controversial clues. And before we reach the end, we'll reveal a fossil so precise, some scientists believe it captured the death of a dinosaur within minutes of impact. If stories like this spark your curiosity, hit subscribe and join us on more deep dives into the ancient past. There's so much more to uncover. Stay with us, the ending may surprise you. It started with a flash of light and ended with fire raining from the sky. An asteroid the size of a mountain slammed into what is now Mexico's Yucatan Peninsula, striking the Earth with unimaginable force. Traveling faster than a bullet and hitting with the energy of more than 10 billion nuclear bombs, it turned seawater to vapor, vaporized bedrock, and opened a crater over 100 miles wide. The explosion ejected molten debris into the atmosphere and triggered a planet-wide chain reaction. Across the Western Hemisphere, wildfires ignited almost instantly. Shockwaves flattened forests. Tsunamis rolled inland for hundreds of miles. But on the other side of the planet, the disaster unfolded more slowly. In places like Asia or Antarctica, the sky was still blue, briefly. The extinction wasn't simultaneous. Some creatures may have survived the initial blast, unaware of what had just happened. For them, the world was ending quietly, second by second. In North Dakota, a remarkable fossil site preserves what may be a snapshot of this exact moment. Fish, turtles, and even a dinosaur limb buried together in a turbulent sediment layer. Embedded in the gills of fish are tiny spherules, microscopic beads of glass that formed from vaporized rock and fell like hail. These animals died not in the blast, but in the fallout, within minutes or hours of impact. This isn't just a fossil bed. It might be a timestamp, the opening frame in the film reel of extinction. The asteroid struck a lethal blow, but it was only the beginning. The real destruction came in the days and years that followed, not through fire alone, but through cold, hunger, and a world that could no longer sustain the giants who once ruled it. The asteroid didn't just bring fire, it brought darkness. In the days after the impact, the skies filled with ash, sulfur, and fine particles of pulverized rock. As this material spread through the atmosphere, it blocked sunlight around the globe. Temperatures plunged. Photosynthesis stopped. The world began to starve. What does a world without sunlight look like? Imagine a decade-long twilight. No crops, no warmth, just the slow erasure of life from the planet's surface. Plants were the first to go. With no sunlight, forests wilted and collapsed. Herbivores followed. Without plants to eat, they died off rapidly, and the carnivores who relied on them soon faced the same fate. In just a few months, the foundation of entire ecosystems crumbled. But this wasn't a short-lived catastrophe. Based on geochemical data from ocean sediment cores, scientists believe that light levels remained critically low for nearly a decade. That's not just climate disruption, it's a full ecological reset. Some regions may not have seen stable recovery for tens of thousands of years. And the transformation wasn't just on land. In the oceans, plankton, tiny organisms that form the base of the food web, were decimated. Marine ecosystems collapsed just as rapidly as those on land. Coral reefs vanished. Shellfish populations crashed. Few environments were spared. Fossil evidence shows a sharp spike in fungal spores immediately after the impact, organisms that thrive on decay. With plants gone, fungi flourished, feeding on the global die-off. It's a chilling ecological marker, a world where death had become the dominant force. We're used to thinking of disasters as explosive and immediate, but this was a slower kind of apocalypse, less cinematic, more suffocating. And in a world where modern climate events are unfolding with alarming speed, the story of the impact winter isn't just ancient history. It's a reminder of how quickly life can be disrupted and how long recovery can take. Not everything died the day the asteroid struck. In fact, some life may have continued on, briefly, as the rest of the planet crumbled. While the immediate impact devastated the Americas, its reach wasn't instantly global. On the far side of the world, in places like Asia, Antarctica, or Australia, the sky didn't go dark right away. For a short time, the forests still stood. Rivers still flowed. Some animals may have continued their routines, unaware that Earth's systems had already begun to collapse. This possibility has led some scientists to consider the idea of staggered extinction, where species in certain regions survived for days, weeks, or even months after the impact, buffered by geography and luck. The global fallout took time to spread, and some ecosystems may have resisted collapse a little longer. Supporting this idea are fossil sites that show no immediate signs of destruction at the boundary layer, no burn layers, no sudden drop in species, no spike in soot. In some sediment records, plant and animal diversity tapers gradually, not abruptly, suggesting a slower die-off. One example comes from Central Asia, where some paleontologists have identified dinosaur fossils just above the KPG boundary, in layers that lack the usual disaster markers. Whether this represents true survival or simply geological distortion is still debated, but it keeps the question open. If even a few dinosaurs lived beyond impact day, their world would have looked increasingly alien. Forests turning grey, temperatures dropping, prey vanishing. It's a haunting thought, a lone herbivore drinking from a quiet stream, beneath a sky already dimming, alive but without a future. Because sometimes the end of a species isn't a sudden fall. It's a long walk through a dying world. What do you think? Could some dinosaurs have truly survived for days or weeks after the impact? Let us know your thoughts in the comments. We read them all, and your theories might inspire a future video. The KPG boundary, a thin layer of clay enriched with iridium, is the geological signature of the asteroid impact. Below it, dinosaurs fill the fossil record. Above it, they're gone. Or so the standard story goes. But in some places, that boundary isn't as clean as it seems. In the western United States and parts of Asia, paleontologists have discovered dinosaur fossils in layers just above the extinction line. These include bones from hadrosaurs and horned dinosaurs, species believed to have died out on impact day. If these fossils were buried after the asteroid struck, they would rewrite the timeline of extinction. The controversy is fierce. Some scientists argue that these bones prove short-term survival in isolated pockets. Others say they're victims of a process called reworking, where bones from older layers are unearthed by erosion or flooding and redeposited into younger sediments. But not all cases are easily dismissed. One hadrosaur femur was found less than a meter above the boundary layer, in sediment that showed no signs of disturbance. Its condition was pristine, articulated, unweathered, and lying in what appeared to be undisturbed ground. If the dating holds, it could be the footprint of a dinosaur that lived not just before the impact, but after it. And while the possibility of reworking looms large, some cases remain difficult to dismiss. When a cormoon lies undisturbed, pristine, and chemically consistent with its layer, it raises a deeper question. What if at least one dinosaur really did outlive the blast? Yet caution remains. The fossil record is notoriously incomplete, and misinterpretation can lead us astray. Bones can move, layers can mix, time can blur. Still, these finds suggest that the extinction wasn't a single cliff, but a fading trail. Each fossil near or above the boundary is like the echo of a final footstep, perhaps misplaced, perhaps real. But either way, a reminder that endings are rarely as sharp as we want them to be. If you love exploring the blurred edges of ancient history, check out our ebook, Secrets of the Ancient World. It dives into lost civilizations, mysterious technologies, and unsolved puzzles that history books often skip. You'll find the link in the pinned comment. The fossil record tells a story, but sometimes it tells it out of order. When paleontologists find dinosaur bones above the KPG boundary, it's tempting to see evidence of survival. But geology isn't static. The Earth shifts, erodes, and reworks its layers over millions of years. What looks like a clean timeline is often a scrambled archive. One of the main challenges is a process called reworking. In dynamic environments like floodplains, older fossils can be dislodged by natural forces, washed out of ancient layers and redeposited into younger sediments. Without careful analysis, a 5 million-year-old bone can end up looking like it came from the world that followed. But fossils don't come with timestamps. To unravel their true age, scientists dig deeper, literally and chemically. That's why scientists use more than just depth to date fossils. They examine the surrounding sediment, look for signs of erosion, and run geochemical tests, measuring isotopes like uranium and lead locked inside the bone. In one notable case, a hadrosaur femur was found just above the extinction layer. The sediment appeared undisturbed, the bone intact. But chemical analysis revealed its isotopic signature matched older fossils buried far below. The femur hadn't outlived the asteroid. It had simply been moved by time. This is the danger of drawing hard conclusions from soft data. A single displaced fossil can create the illusion of survival, when in fact, it's a geologic ghost. Still, not every post-boundary fossil shows signs of reworking. Some may be genuine, but in a record this fragile, the line between last breath and last trace is perilously thin. In the end, we're left piecing together history with broken tools. And sometimes, the closer we think we are to the truth, the more we realize we're looking at an echo, faint, disjointed, and nearly lost in the shifting sands of time. If you're enjoying this journey through time and want to support the channel, consider clicking the Super Thanks button. Every bit helps us keep exploring history's greatest mysteries. And yet, while the giants faded, something smaller had already taken flight, literally. Dinosaurs didn't all vanish when the asteroid hit. One lineage survived, not by being the biggest or strongest, but by being small, adaptable, and lucky. We know them today as birds. By the late Cretaceous, birds had already split off from their dinosaur ancestors. They shared many traits with their theropod cousins: feathers, hollow bones, fast metabolism, but they had begun to specialize. Many were capable of flight. They hatched from eggs, grew quickly, and likely responded fast to environmental changes. These traits mattered after the impact. While large herbivores needed forests and vast food supplies, birds could survive on seeds, insects, and carrion. Some species likely foraged in debris-rich landscapes. Others may have flown or migrated to safer habitats. Their small size meant they needed less to survive, and their reproductive speed gave them an edge in a collapsing world. And then there's the fossil record. In Antarctica, researchers uncovered the remains of Vegavis, an early bird that lived right at the boundary of extinction. Its bones suggest that some bird lineages endured not just on warmer continents, but even in polar regions. That survival in extreme conditions, months of darkness, freezing temperatures, adds weight to the theory that flexibility, not dominance, shaped the survivors of the KPG crisis. So when we say the dinosaurs are extinct, it's only partly true. Over 10,000 bird species alive today are living descendants of those survivors. Every morning song, every feathered wing in flight, is a direct continuation of the Mesozoic. So the next time you see a sparrow or hear a hawk cry overhead, remember, you're watching the dinosaurs that made it. The Age of Dinosaurs didn't end. It changed shape. What lives on isn't just a remnant of the past, but a reminder that survival often comes down to one thing: the ability to adapt when everything else falls apart. If we judge the end of the dinosaurs by what's in the fossil record, we have to confront a simple truth. Most of the story is missing. Fossils only form under very specific conditions: quick burial, low oxygen, minimal disturbance. Most of Earth's environments don't preserve life well, and many never did. Forest floors rot quickly, mountain slopes erode, polar regions freeze and thaw, destroying delicate remains. That means entire ecosystems could vanish from the record without leaving a trace. And when you consider the vastness of Earth's surface, the scale of what's missing becomes clear. In fact, geologists estimate that less than 1% of the sedimentary rock layers from the late Cretaceous and early Paleocene have been studied for fossils. That's not a data gap, it's a black hole. Some regions, like parts of Central Asia, Antarctica, and the Southern Hemisphere, remain almost entirely unexplored from this period. If isolated dinosaur populations did survive briefly after the impact, they may have lived and died in places that simply didn't preserve their bones. Even in well-studied regions, erosion can erase entire layers, and modern landscapes can bury ancient secrets too deep to reach. Roads, cities, and farmland now sit atop ancient worlds we may never uncover. This isn't just a scientific limitation, it's a psychological one. Humans are wired to draw conclusions from the information in front of us. But sometimes, what we're missing matters more than what we have. It's possible we'll never find fossils from the last days of dinosaurs, not because they didn't exist, but because their traces were lost to time. Or maybe they're still out there, waiting in some unexcavated hillside or eroded cliff, holding the final pages of a story we've only begun to understand. Want to dive even deeper? Secrets of the Ancient World uncovers incredible stories from Atlantis and Angkor Wat to the real tech of the ancients. Grab your copy via the pinned comment and keep the adventure going. Could some non-avian dinosaurs have outlasted the blast? It's a question scientists continue to ask, not because we've found conclusive proof, but because pieces of the puzzle suggest survival might have been possible in the right conditions. Most dinosaurs vanished rapidly, but some researchers have proposed that small, isolated populations may have lingered for a time in remote or sheltered environments, far from the worst of the impact's aftermath. High-altitude terrain, polar regions, or island ecosystems might have buffered the shock, at least temporarily. The fossil record hints at this possibility. In Alaska, late Cretaceous dinosaur remains have been found in what would have been a polar latitude at the time. These animals likely endured long periods of darkness and cold, suggesting that some dinosaurs were already adapted to extreme conditions before the asteroid hit. If any group could have survived the nuclear winter that followed, it may have been them. There's also the matter of dinosaur diversity in the final few 100,000 years before the impact. Some species were shrinking in size, reproducing faster, and filling more specialized ecological roles. These traits, mirroring those of birds and mammals, could have given certain lineages a brief advantage in a dying world. We don't yet have the fossils to confirm post-impact survival, but the possibility lingers in the silences of the record. Somewhere, perhaps in a shadowed valley or distant forest, a few dinosaurs may have held on, days, weeks, maybe even longer. If so, theirs would have been a quiet extinction. No final battle, just a slow fading. As light disappeared, food vanished, and the last giants passed into memory, unseen and unrecorded. We like our endings sharp. One moment, the world is full of dinosaurs. The next, they're gone. It's a cleaner story. It gives us a clear before and after. But extinction rarely works that way. In truth, most mass extinctions, including the one at the end of the Cretaceous, are uneven, drawn out, and full of uncertainty. Yet humans are wired to crave clarity. Studies in psychology have shown that we instinctively prefer singular causes over complex chains of events, especially in times of crisis. A single asteroid explains everything. A slow ecological unraveling? That's harder to process. This bias shows up even in science. When the asteroid theory gained traction in the 1980s, it met resistance not just because of gaps in evidence, but because it disrupted the prevailing belief in gradual extinction. It reversed the narrative from slow decline to sudden catastrophe. And now, decades later, the pendulum swings again. As new data suggest, the end may not have been so immediate after all. We don't just want to know that the dinosaurs died. We want to know when, how, and what the final moment looked like. But the fossil record resists that kind of neat resolution. It's broken, partial, and often silent where we most want answers. That discomfort resonates today as we face our own slow-moving global threats: climate change, biodiversity loss, ecosystem collapse. We still look for single causes, singular moments to blame. But the truth is more complicated. Extinction doesn't always arrive with a bang. Sometimes it whispers in, step by step, until one day, it's simply too late to reverse. And maybe that's the most unsettling ending of all. The kind that doesn't feel like an ending until it already is. So, how long did dinosaurs survive after the asteroid? The answer is less like a stopwatch and more like a slow, unraveling story. The impact itself was devastating. Everything near the blast zone was annihilated in minutes. But the extinction that followed took time, and it didn't look the same everywhere. Some species may have perished instantly. Others, in distant or buffered environments, might have endured for days, weeks, or even months before food chains collapsed and climate chaos took hold. A few bones found just above the extinction boundary tempt us with that possibility, but the line between survival and sedimentary illusion is thin. Still, we've learned a lot. The fossil record shows that life didn't end uniformly. It fractured, ecosystem by ecosystem, species by species. The skies darkened, temperatures plummeted, and even the oceans turned hostile. In the end, most of the giants were gone. But not all. Birds, small, lightweight, fast-breeding descendants of theropod dinosaurs, crossed the boundary. They weren't the most dominant creatures. They didn't command the food web, but they were adaptable, opportunistic, and able to survive in a world turned upside down. It's tempting to look for a single, final moment, the last dinosaur's final breath. But that moment may never be found. Instead, we see traces, footprints fading into the dust, fossils just barely beyond the line, and genes that live on in feathers and flight. What we know for certain is this: extinction isn't just about collapse, it's about what comes next. And those who made it through weren't the rulers of the old world, they were the architects of the new. The asteroid impact didn't just end an age, it triggered a long, uneven collapse, a wave of extinction that spread across land, sea, and sky. Some creatures died in seconds, others lasted days, weeks, maybe more. The boundary between survival and oblivion was jagged and full of shadows. And through all the uncertainty, one fossil might capture the moment it all began to change. At a site in North Dakota, scientists uncovered the leg of a dinosaur, preserved in exquisite detail, fully intact, buried in riverbed debris. Nearby were fish fossils, their gills filled with glass spherules formed from molten rock blasted into the atmosphere. These beads fell back to Earth minutes after the asteroid impact. Together, they may record one of the first victims of the extinction, fossilized not weeks or years later, but within an hour of impact. A moment frozen in sediment, a death caught at the turning point of history. But not all dinosaurs vanished. Birds, the last surviving dinosaurs, adapted and endured. They evolved. They filled empty skies. They sing from rooftops, soar above cities, nest in the forests that grew after the fire. Their survival wasn't guaranteed. It was earned through flexibility, resilience, and luck. Extinction is never just an ending. It's also a test of what comes after. What survives isn't always the strongest, but the most adaptable. Thank you for exploring the final days of the dinosaurs with us. If this journey sparked your curiosity, support Armchair Archaeology by subscribing and ringing the bell. There are more ancient secrets to uncover, and you won't want to miss what's buried next. What stories from deep time do you want us to uncover? Let us know in the comments below. Until then, keep exploring, keep questioning, and keep the flame of curiosity burning bright.